Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to continue our conversation about sampling distributions for proportions. You'll recall from the previous video that we looked at this distribution here, which is all of the sample proportions, about 1,400 sample proportions, that were sampled from Timberline students at a sample size of 40. The claim was that 67% of students that graduate from Timberline and attend college in the state of Idaho. So what we were doing is we were taking samples of size 40 students and looking at, out of the sample, how many of them attended college in the state of Idaho. You can see this last one we took was almost identical to the population proportion, and it is 0.675. You'll also recall from our first video, from yesterday's video, that this population proportion is called P. This is the true proportion for all students. This sample proportion, that's of those 40 students, is a P hat, and this represents an individual sample. Now, the P, again, is the population proportion, and P hat is the sample proportion. Each of these dots in this dot plot represents a P hat, a sample proportion. And we talked in the last video about how it takes on a roughly normal distribution given certain conditions. Today's video is going to elaborate on those conditions. So let's go back and let's reset this plot. And let's say that instead of a sample of size 40 with a population proportion of 0.67, let's say we found out instead that 97% of students attended in-state school. So here now the population proportion is 0.97, and I'm taking the same sample size. If I start taking samples, let's do 10 at a time here. Here I've gotten quite a few, about 100 or so. You can see this is not looking very symmetric. It's looking a bit skewed. Well, let's take some more samples. Let's go by 100 at a time. And as we continue here, you can see that the dot plot continues to be skewed to the left. Now, if I take about 1,400, which is the same we took previously, you can see that it never becomes normal. Instead, it takes on a heavy skewed left distribution. Well, let's look at a second scenario. Let's say instead of 97% attending school in the state of Idaho, let's say it was only 10% and everybody else went out of state. So let's do this again here. We'll just jump into the 100 at a time thing. We're going to take about 1,400 samples. Remember that each of these dots on the dot plot represents a sample proportion from a sample of size 40. And you can see again here, we don't get a nice normal curve, but we get a skewed right curve. Not as heavily skewed as the previous one, but still skewed right. So here, the sampling distribution, again, did not turn out to be approximately normal. So we have to ask ourselves, when will this sampling distribution be normal and when will it be skewed? Well, it turns out that if we look at the ratio of sample size and the population proportion, if this value of sample size times the proportion is at least 10, then we end up with something that's approximately normal. And then conversely, the sample size times 1 minus the population proportion needs to be at least 10. If both of these hold true, then we end up with a sampling distribution that's approximately normal. So what we're saying is that we want to expect at least 10 successes and at least 10 failures in whatever we're looking at in order for the distribution to turn out to be approximately normal. I hope you enjoyed today's video. Thank you for joining us and have a great day.